Hey Hayden, this is Miss Tracy. So let's start with quiz 21 and work our way through the rest of your questions. So, only 3/8 of the university students wanted to become math teachers. So that is our portion or our percentage of the students that wanted to become math teachers. So we know that 3/8 wanted to be math teachers. Okay, so the ones who wanted to be math teachers. So we have future math teachers, and then we have those who did not, so not, want to become math teachers. So here we have our proportion, and here we have a quantity. 3,500 did not want to become math teachers. So how many were there? So if 3 out of 8 did want to be math teachers, then that tells me 5 out of 8 did not. Does that make sense? Because 3 plus 5 is 8. 3 out of 8 did want to be math teachers, then 5 out of 8 did not want to be math teachers. And that equaled 3,500. There's your proportion statement right there. 5 over 8 is equal to 3,500 out of some total number that we don't know. All right. So now we can just cross multiply. 5 times x is 5x. And 8 times 3,500. I love this new software I have because my calculator, I can use it. And then when I click down on here, it does not go away, which is nice. The other one goes away whenever I click, and I have to go back and forth a lot. 8 times 3,500. It also shows me what I'm doing, which is nice. All right, so that's 28,000. See what I mean? I don't have to guess at what was on the calculator or try to remember it. It stays, which is nice. So now we just divide both sides by 5. And that'll give us the value of x, which tells us total. So I take this number and I divide it by 5. And that's 5,600. That's how many total students there were. Okay. Now, the other way that you could set this up is to not use the fraction, right? You could use, you could say the ones that did want to be, or you could just say yes, right? They said yes to math. These said no to math. And there is a total. You could say 3 out of 8 said yes to math, which meant 5 out of 8 said no. And that 5 out of 8 equal 3,500. You'd still end up with the same thing. You would just put those, like we don't know the total, and then you would still set it up like this. It's just all about how you need to visualize the problem. What do you need to see in order to set this up appropriately? Okay? All right, let's move on to the next problem. All right. The velvet bag contains 13 gold coins and 5 silver coins. So we have a bag. I'm just going to write bag right here. This is our bag, right? In that bag, we have 13 gold and 5 silver. That gives us a total of 18 coins. Okay, with me so far? A coin is randomly drawn from the bag and it is not put back. It's not replaced, so it stays out. Then a second coin is randomly drawn. What is the probability that both coins are gold? Gold. We want gold, gold, and then that is without replacement. So when we take the first gold coin out, we have a probability. There's 13 gold out of a total of 18, so it's 13 over 18, okay? But when we take that one gold coin out, all right, we take that one out, now we have 12 gold coins and 5 silver coins for a total of 17 coins. So when we try to pull that second gold coin out, the probability changes to 12 over 17. You have to account for each individual event the way that it looks, right? When we took that one gold coin out, we had to adjust our totals, which affects the next probability fraction. Now we multiply. Now, one of the things that I see here is that I can divide 18 and 12 by 6. So I'm going to do that. This becomes a 3. This becomes a 2. That's going to make my math a little bit easier. 13 times 2 is 26. And 3 times 17 is 51. And I believe that is as far as I can reduce that fraction. And that would be your answer. Okay? All right, let's look at the next one. All right, if f of x is equal to x squared plus 2x plus 2, find m minus 1. So all you're doing is you're taking whatever is in this parenthesis for the function f, and you're substituting for x in the function f. So that means we have m minus 1 squared, because that takes the place of x, plus 2 times m minus 1 plus 2. So you see, wherever the x was, I just put in this value. That's all you're doing. It's just a substitution. So now we just do the math. So I'm going to say m minus 1 times m minus 1 plus 2 times m is 2m, and 2 times negative 1 is negative 2 plus 2. M times m is m squared. M times negative 1 is negative 1m. Negative 1 times m is negative 1m. And negative 1 times negative 1 is a positive 1. Okay, that's all of that. Plus 2m minus 2 plus 2. All right, now we can combine like terms. So I have m squared. There's not any other squares. That's a negative 2m plus 1 plus 2m. And then negative 2 plus 2, well, that's 0. So we can just, those cancel each other out. All right, so negative 2m, positive 2m, they cancel each other out, right? So all I have left is m squared plus 1. That's your answer. All right, let's look at the next one. All right, in this one, it says solve by graphing. So I've got a little graphing paper for us right here. So I'm going to create a, what do you call it, Cartesian coordinate system, an x and a y plane. Here's my y-axis, and right about here, let's do my x-axis. There we go. I'm going to use red for this line right here. We're going to solve, when we solve by graphing, whenever we solve these problems here, what we're solving for is the point of intersection. That point that we're looking, when we solve for x, we solve for y, we're looking for the point of intersection. So we're going to solve this by graphing this line. This is a slope of 1, which is 1 over 1, and the place where it crosses the x-axis is negative 2. So we find negative 1, negative 2. We put our dot right there. Okay, now the slope is 1. 1 over 1, we can make that a fraction by putting it over 1 because it's a whole number. So it's up 1 over 1, up 1 over 1. So up 1 over 1, up 1 over 1, up 1 over 1. There's our line, and I'm just going to draw my line through those points. There we go. That was pretty good. All right, so now I'm going to use green for the other line just to keep them straight. All right, so y is equal to 3x. When there is no point out here, that's because it's plus 0. And mathematicians are lazy, so we don't write it if it doesn't do anything to add to the equation. But in order to graph it, you need to know that that plus 0 is your y-intercept point. So this would go right here. Now the other thing that you could do, you could always go back to doing your table. Here's x, and then here is the formula. 3x, and here's y, right? So if x is 0, 3 times x is 3 times 0, which is 0. So your point of interception here is 0, 0. That's a point on the line, right? So our slope is a whole number 3, so we make that a slope by putting it over 1, make it a fraction. Any whole number becomes a fraction by putting it over 1. So now that means that we're going to go up 3 over 1, up 3 over 1, because it's positive, up 3 over 1. So what I'm going to do is I'm going to show you that on here. 1, 2, 3 over 1, right? So if x is 1, 3 times 1 is 3. So the x is 1 and the y is 3. If x is 2, the next point, then 3 times 2 is 6. That means that if x is 2, then it should be right here. Let's see. Up 3 over 1. That's exactly right. So that means if we keep going in this direction, this should be down 3 and over 1 the other direction. Down 3 over 1. So we could draw our line through these points, and we have our solution. Our point of interception is going to be -1, -3. That's the answer. That is what we solve for every single time we do these problems. We are solving by graphing. Let me erase this, and I will show you exactly what I'm talking about. So, if we were to use substitution in this, we know the value of y is 3x. So I could substitute 3x for the y here, right? So 3x is equal to x minus 2, because that's what y is equal to. So then that allows me to subtract x from both sides. I'm sorry, it should be an x, because that's a 1x, right? So then that's 2x is equal to -2, right? Divide both sides by 2. X is equal to -1. X is equal to -1. So if I go back in and I substitute that in here, y is equal to 3 times -1. That's -3. Y is -3. And it would even work if I put it in here. Then that would be -1 minus 2, which is still -3. -3. Every time we use substitution or elimination for these problems, that's what we're doing. We are solving for the point of interception. So you can solve any way you want to. Graphing, which, quite honestly takes longer and it's harder to see. The whole point of learning elimination and substitution first was to show you that that's what we're doing. We're solving for those points. Now that was substitution. If I used elimination, I would have to multiply this by -3. So then that would be -3y equals -3x plus 6. If I multiply this all by -3, right? Then that would give me y is equal to 3x. Right? Now I just multiply the top one by -3. So then these would cancel, and I would have -2y is equal to a positive 6. Divide both sides by -2. Y is equal to -3. It doesn't matter how you solve it. And if I put that in here, -3 is the value of y. That's 3x. Divide both sides by 3. Then -1 is equal to x. Doesn't matter whether you solve it by substitution or elimination or graphing. You're going to get the same answer if you do the steps correctly. Okay? So if it is one that you struggle with, solving by graphing, you can use another method. We just want you to understand that you're doing the same thing regardless. Some people just like to see it visually. This is the visual way to do it. All right, next problem. All right, this problem wants us to solve by elimination. So using that methodology, I'm looking to see what I have in common. I don't have anything in common. All of the terms here are different. Like I can't double this. I can't, to get 24, I can't multiply this, or I can't multiply by -1 to get the opposite. Nothing is opposite. So I'm going to have to multiply and just pick a term. So I'm going to pick 3 and 4. I'm going to pick the x terms. And I'm going to pick, I think I'm going to do this one negative. So I'm going to multiply by the opposite x term, and this will be a -4. I'm going to multiply this by +3, because I need this to be a negative, I need this to be a positive, so that I can cancel them out. So when I do that, -4 times 3x is -12x. -4 times a +2y is a -8y. And -4 times a -12 is a +48. 3 times 4x is a +12x. 3 times 5y is a +15y. And 3 times a -23 is a -69. Now, I'm going to start here. -12, +12, they cancel. So we eliminated those. -8, +15, that's going to be a +7y. And 48, +48 from a -69, that's going to be a -21. So if I divide both sides by 7, y is equal to -3. Now all I need to do is substitute this in one of these. I'm just going to pick the bottom one because it's easy to get to. And I'm going to, I'm just going to rewrite it. 4x plus 5 times -3 is equal to -23. 4x minus 15, because now that's a -15, is equal to -23. Add 15 to both sides. This cancels. 4x is equal to 8. So if I divide both sides by 4, x is equal to 2. So the answer is 2 and -3. That's how you should answer that problem, as a point. So you can see what we did with graphing. We solved for x and y by graphing the line and the place where they intersect. This is the point that we're giving. Whenever we do these problems, we're doing the graphing part without doing the graphing part. We're finding where they intersect without having to draw the lines out. So it's up to you. You can solve any of these problems in any manner, but if you do them all right, you're going to get the same result every single time. All right, let's look at the next one. All right, this one says to simplify. So the very first step always, step number 1, it's always to put everything in proper scientific notation. Okay, that means you need to have a ones place times 10 to a power. Okay, so we need to have a ones place. So I'm going to move my decimal back 1, 2, 3 spaces. So it's -3 spaces because it's backwards 3 spaces to make that 4.5 times 10. And I'm going to combine my exponents, -3 and +5. That gives me +2. Now I'm going to do the same thing here. I know this is supposed to be 7 times 10. Well, I'm going to have to move my decimal forward 1, 2, 3 spaces. So that's +3 +4. That's 7. This one is going to be 5 times 10. And I'm moving my decimal 1, 2, 3, 4 spaces, so it's plus 4. So it's times 10 to the 4th power. And then I'm going to move this back 1, 2, 3, 4. So it's minus 4. All right, whenever it's minus, we're moving the decimal backwards. Whenever it's plus, we move the decimal forwards, right? We moved it forwards here, so it's positive. We moved it backwards here, so it's negative. Okay, so that's 9 times 10, and we have a negative 4 and a positive 3, so it's going to be a negative 1. Okay. All right, now that we have everything in proper scientific notation, we can multiply. We're going to treat it just like a fraction, and we'll do everything in the numerator and then everything in the denominator. And when we get to a single answer, then we'll divide. So 4.5 times 7. I can't do that in my head, can you? So I'm going to multiply it here. 4.5 times 7 is 31.5, okay? So that equals 31.5 times 10. And then we have the exponents. Whenever we multiply bases, the exponents are added together. Positive 2, positive 7, that's a positive 9, right? Now, I'm going to multiply 5 times 9. I know what that is. That's 45 times 10. And I have a positive 4 and a negative 1. That's going to be 4 minus 1 is 3. Okay, so now I need to divide this. 31.5 divided by 45. That's 0.7. So 0.7 times 10. And when I take this and combine it with this, whenever you move, it changes the sign. So 9 minus 3 is 6, right? But now I need to move this back. I need to move that decimal back. So it's going to be one space, so it's minus 1. So that's going to be 7 times 10, negative 1, positive 6. That's going to be a positive 5. That is your answer. All right. You can readjust these as you go if you want to. If you wanted to move this up and make that 4.5 and move this up and make that 3.15, you could, and you would get the same answer. But to me, it is a wasted step because you have to readjust at the end anyway. So just go ahead and divide whatever the numbers are and then fix the answer into proper scientific notation. So our steps, put everything in proper scientific notation. And then step 2, perform calculations or, perform the multiplication of coefficients that these numbers up here, and add exponents for numerator and denominator. Separately. Divide coefficients That's this step. That was this step. This was 1. This is 2. This is 3. You're going to add exponents. And then 4 is the same as step 1. Put everything in proper scientific notation. Okay? That's all we do for these. You've got to do this step in order to do this step. You cannot do this and do it right without putting it in proper scientific notation first. That's the key to being able to solve these. You've got to do the steps. All right, next problem. All right, in this problem, it says write an inequality whose solution set is described by the below graph. So here's what I'm seeing. I'm seeing everything less than 2. Right? This is the x-axis. So x is less than positive 2. That's the first blank. And your domain is equal to integers. Because what do we see? Just the integers are graphed. The line in between is not graphed. It's just the dots. When you see just the dots, the domain is integers. Because we're just graphing the whole numbers. We're not graphing the parts of numbers in between. So it's not reals. It can't be reals, because reals would include fractions and halfway through. Like, it would include negative 3.5. It would include a positive half. It would include, negative 1 3/4. This does not. This is just graphing the integers, so the domain is integers. And that's all you would do for that problem. That's it. All right, this problem said to multiply, and it gave you 4 blanks with plus signs in between. All right, so we're going to multiply. So we're going to multiply the first number times everything, and then the second number times everything. So basically that looks like this. 4 times x squared plus 2x plus 3 plus x times x squared plus 2x plus 3. Right? We're using our distributive property. So 4 times all of these plus x times all of these. We get the plus sign from right here. So this is 4x squared plus 8x plus 12. Now we multiply these. Plus x cubed plus 2x squared plus 3x. Now we combine, and we want to do this in descending order of the variable, because that is the right way to write any type of I guess it's not a trinomial when you have, I guess it's whatever the expression is. The right way to write it is in descending order of the variable, and that's descending degree. So the highest exponent goes first. That's really all you have to remember. The highest exponent goes first. So x cubed is the highest exponent, and there's not another one. So it's by itself, so we can cross it out. We've done that one. Now we've got 4x squared and 2x squared. So plus 4x squared plus 2x squared. Okay, we got those. Now we need our x's. Plus 8x plus 3x. And then we have 12 by itself. Now we can combine like terms. X cubed is all by itself. These two can be added together, plus 6x squared. These two can be added together, plus 11x. And that one's by itself. So you just put these in here. That was not so hard. Not hard at all. You see how easy that was? You just have to distribute and multiply this number times all of these, like we did here, and this number times all of these. And if it helps you to write this out like this, do this step. This is all we're doing. This one times all of these, plus this one times all of these. All right, write it out like that if it makes you see it better. Do the things that you need to do to understand the problem. All right, let's do the next one. All right, in this problem, we were supposed to add. It says do not distribute. Write the numerator in the top blanks and the denominator in the bottom. So in the numerator, you had a term plus a term minus another term, and you had one term in the bottom. So we are not going to distribute. We're just going to find a common denominator. And what it means by do not distribute is it means if this is a term by itself, Don't combine it with anything. Just leave it separate. So we have a squared, b plus a, and a is our denominators. Well, this a can be contained in here because there's two of these. There's one of these. So our denominator, our common denominator here is going to be a squared times b plus a, right? That's our common denominator. So that's what we're going to multiply everything by. So a squared times b plus a times 4 over a squared minus a squared times b plus a times 2a over b plus a plus a squared times b plus a times 3 over a. Now we're going to reduce. So the a square on the top and the bottom can be reduced. So what we have here is 4 times b plus a minus. This can be reduced because when you multiply and divide by the same number, it cancels each other out, right? It just means 1. So this is going to be a squared times 2a. That's going to be 2a cubed because we add the 2 and the 1, right? And then the a, one of the a's in here is going to cancel one of the a's in here. So basically, this just becomes a times b plus a. So that's going to be plus 3a times b plus a. And all of that is over a squared times b plus a, because that is the common denominator. So that's what you would put in here. 4 times b plus a. And then this would be 3a b plus a, because this is plus. And then the minus is 2a cubed. And then you put a squared b plus a in the bottom. Let me double check, make sure that's right. All right, so it's exactly the way that you see it. I had it backwards. I had this plus and this minus. It's exactly in the order that you see it here, the way we solved it. So that is the way that you want to do it. You want to type in each term exactly the way that you see it and the denominator in the bottom. So I didn't change anything or rearrange anything. And the do not distribute part means you just leave it like it is. We're not putting 4b plus 4a. You just leave it 4 times b plus a, so you don't have to do that part. All right, let's do the next problem. All right. Hey, come on, dude. Find the lateral surface area of this right prism whose bases are regular pentagons. All right, this is a key word. Regular pentagon. That means it's regular. What does regular mean in geometry? It means all the sides are the same, right? So that means if this side is 10, then this side is 10. And 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 if this is 25 tall, then this is 25 tall, right? And this one is 25 tall. And then this one is 25 tall. They're all the same. So you've got 5. Pentagon is 5. You could also count 1, 2, 3, 4, 5 sides. So you got 5 sides exactly the same. Lateral surface area. What does lateral mean? Lateral means sides. We don't care about the top and the bottom. It doesn't matter. We're not looking for the area of the top and the bottom. We're looking for the sides. We have 5 sides that are exactly the same. And guess what? Those sides, they're rectangles. They are 10 feet by 25 feet. And there's 5 of them. So we just multiply. So that would be 5 times 250 feet squared. Right? So 5 times 250, I know 4 times 250 is 1,000. So it's going to be another 250. So 1,250 feet squared. Math is logic. You have got to use your brain to see what's out there, to see the problem. Take it apart. Understand it, okay? You have 5 rectangles around the edge of this pentagon, and we only wanted to know what those 5 rectangles were. Okay, regular means they're all the same, so you can multiply by however many there are. You've got to pay attention to your key words. All right, let's see what the next one is, if there's a next one. All right, here we are looking for a base of a right solid whose height is 20 meters shown. Find the volume of the solid. Dimensions are in meters. Okay, so we need to find the area. So volume is equal to area of the base times height, right? We already know the height. The height is 20 meters. So we need the area of the base times 20 meters. We just need to find this. So we got to find the area of this times 20 meters. So this is a half circle, right? And then this looks like a rectangle. It's already divided for us. This rectangle is 30 by 16. So the area of the base is equal to the rectangle plus the half circle, right? We can see that. The area of the rectangle is 30 meters by 16 meters. And the area of the half circle, that's going to be pi r squared divided by 2 because it's half of a circle. And the radius is 8 meters. So I can substitute that in, and I can say 8 meters squared. So we're going to add those two together. All right, so if I go ahead and I say 30 times 16, that's 480. So 480 meters square plus I've got 8 squared, so that ends up being 8 times 8, right? 8 times 8, that's 64. So I've got 64 times pi divided by 2, and that's meters squared. 64 divided by 2 is 32. So I've got 480 meters squared plus 32 pi meters squared. This is the area of the base. So I can substitute that in over here. So I can say 480 meters square plus 32 pi meters square times 20 meters. So if I go ahead and I say 480 times 20, I get 9,600, and meters square times meters to the 1 power, we add the exponents together, that's meters cubed, which is volume, because that's what we're looking for. And now I'm going to say 32 times 20 is 640. So 640, I've still got that pi symbol, and meters squared times meters to the 1, it's meters cubed, right? So we don't usually write it like this, though. We write it as short as possible because mathematicians are lazy. So we write 9,600 plus 640 pi meters cubed. Because we don't like writing more than we have to. Mathematicians are lazy. So they don't want to write meters cubed twice. They want to write it one time. Because it's redundant when you have to write the same thing over and over again. It gets on your nerves, right? Mathematicians are also annoyed. So they don't like to write the same thing over and over again. They want to write it as quickly as possible. So this is what we do. And all this really tells us is that we distribute the meters cubed to everything inside the parenthesis. So everything inside the parenthesis is meters cubed. And this is how you would write your answer. And this is the last one for quiz 21.